Welcome back, everybody, to another deep dive. This time we're taking a look at biohacking. Engineering meets human biology, and this one's brought to you by Samurai Kaizen. And of course, you know what to do. Hit that subscribe button to keep getting more of these deep dives into all sorts of fascinating topics.
Yeah.
So biohacking itself is a pretty incredible concept.
Yeah.
And today we're going to go beyond the hype. We're going to uncover some of the real potential here.
Sure.
But also some of the very real risks and ethical considerations.
Yeah.
We've got a lot of research here and expert opinions to go through. And so our mission is to distill it all into some clear, actionable insights.
Okay.
So you can really understand this complex field.
Sure.
Ready?
Yeah, let's go.
Okay, let me dive in. First up, innovations. Some of the incredible things that are driving the biohacking movement. We're talking gene editing, implantable devices. The future is now.
It is.
Okay, gene editing. That's one I really wanted to talk about. CRISPR-Cas9. This is the big one.
Yeah.
It's described as molecular scissors. But what does that even mean, and why is it such a big deal?
So CRISPR basically allows us to target a very specific DNA sequence and modify it with very high precision.
Okay.
So that in itself has like huge implications because we're basically editing life at the most basic level, right? And it's already having a real impact in treating genetic disorders and stuff like that. So one remarkable example is exa-cel, which is a CRISPR therapy that was recently approved by the FDA for sickle cell disease and beta thalassemia.
Right.
And what's really revolutionary about exa-cel is that it offers a potential cure, not just a treatment.
A cure. That changes everything. So, I mean, what are the implications of moving from managing symptoms to actually eliminating genetic diseases?
Well, I mean, it's a completely different paradigm in healthcare, right? If you can imagine a world where inherited diseases can be eradicated.
Right.
But then it also raises questions about accessibility, cost, and also, you know, even like the definition of what's normal human variation.
Yeah.
I mean, we're entering uncharted territory here, and the ethical considerations are really profound.
It's incredible.
Yeah.
But it's also kind of daunting, right?
Yeah, for sure.
No, we've also heard about base editing. This is another gene editing technique.
Yeah.
How is it different from CRISPR, and what advantages does it offer?
So CRISPR-Cas9 makes double-stranded cuts in the DNA, whereas base editing acts more like a pencil and an eraser.
Okay.
So it makes single changes in the genetic code.
Right.
So it's a more precise, more subtle technique.
Gotcha.
And this is crucial because it reduces the risk of what we call off-target effects, which are basically unintended modifications that could have unpredictable consequences.
Yeah.
So, you know, minimizing those unintended consequences and making gene editing even safer and more targeted.
So it's all about really fine-tuning the control we have. Now, gene editing is obviously pushing boundaries, but it's not the only biohacking innovation that's turning heads.
No, not at all.
We've got implantable devices, things like RFID chips, brain-computer interfaces, BCIs, Neuralink. What do you think about all that?
Well, I mean, implantable devices are really blurring the lines between technology and biology.
Right.
So RFID chips, for example, are already being used for things like identification, access control, that sort of thing.
Right.
But then you have BCIs like Neuralink, which are aiming to do much more, you know, from restoring mobility for people with paralysis to even potentially treating neurological conditions.
Neuralink has certainly sparked a lot of excitement and controversy.
Yeah, for sure.
What are some of the potential benefits and risks of implanting a device directly into the brain?
Well, I mean, the potential is really immense, right? I mean, imagine restoring sight to the blind or allowing someone with quadriplegia to control a computer with their thoughts. It's amazing, but at the same time, it also raises very serious concerns about privacy, security, and, you know, also the potential for unintended consequences. We're talking about altering brain function here.
Yeah.
And the long-term effects, I mean, who knows?
If you just don't know, it's a delicate balance between, you know, pushing the boundaries of human potential and ensuring that we're doing it safely and ethically.
Absolutely.
Now, let's shift gears a little bit to biohacking technology that's a little bit more familiar to folks. And that is wearable tech.
Yeah.
It seems like everybody's got a smartwatch or a fitness tracker these days. How do wearables fit into the broader biohacking movement?
Well, I think wearables are becoming increasingly sophisticated in monitoring our health and performance. So you have things like continuous glucose monitors or CGMs, which are revolutionizing diabetes management.
Yeah.
They provide real-time blood sugar readings. Smartwatches can now detect atrial fibrillation, which is a heart rhythm disorder that can lead to stroke.
Right.
And, some wearables even claim to improve sleep quality and reduce stress.
Yeah, I've heard that. I have a friend with diabetes, and she was telling me that her CGM has been an absolute game changer.
Yeah.
She just feels more in control,
Yeah.
and less anxious about managing her condition.
Makes sense.
We've also heard about transcranial direct current stimulation, or TDCS. It's a non-invasive brain stimulation technique
Yeah.
that's gaining popularity as a potential cognitive enhancer.
Yeah.
Can you explain how that works and what the research says about its effectiveness?
So TDCS basically involves applying a weak electrical current to specific areas of the brain using electrodes that are placed on the scalp.
Okay.
And some studies suggest that it may have modest effects on cognitive functions like memory, attention, learning, things like that. However, the research is still in its early stages, and the long-term effects are really unknown at this point.
So while it may hold promise, for boosting brain power, it's important to proceed with caution.
Yeah, absolutely.
Be aware of the potential risks. How does TDCS compare to a more invasive approach like Neuralink, where you're actually implanting electrodes directly into the brain?
Well, I think it's a trade-off between invasiveness and precision.
Okay.
So, Neuralink, with its surgically implanted electrodes, offers a much higher level of precision and control over brain activity.
Right.
But obviously, it comes with the risks associated with surgery and the potential for long-term complications.
Sure.
TDCS, on the other hand, being non-invasive, is considered safer, but it may be less effective in treating more complex neurological conditions.
So it's fascinating to see how all these different technologies
Yeah.
are addressing, similar challenges, but with varying degrees of invasiveness and risk.
Absolutely.
So we've covered some amazing innovations, but as with any powerful technology, there are always some potential downsides.
Oh, yeah.
Some risks to consider.
Absolutely.
So let's shift our focus now to some of those potential negative consequences of biohacking. What are some of the things we need to be thinking about? What are the risks? What are the ethical concerns?
Well, one major concern with gene editing, especially with CRISPR,
Right.
is the possibility of what we call off-target edits.
Okay.
And these are basically unintended modifications to DNA sequences.
Okay.
Other than the target,
Okay.
and these could potentially lead to unforeseen health problems.
Right.
Even potentially increasing the risk of things like cancer.
Wow.
And then when you talk about germline editing, where those changes would be inherited by future generations, the ethical stakes become even higher.
Yeah, it's like we're suddenly stepping into the role of designers of future generations.
Exactly.
And that just raises all sorts of ethical questions about what is a desirable trait and who gets to decide.
Yeah, and those questions become even more complex when you consider that, access to these technologies might not be equal. And so you could potentially create a society where certain groups have an advantage.
Yeah.
Based on their genetic enhancements.
That raises concerns about just exacerbating existing social inequalities.
Exactly.
You don't want a world where only the wealthy
Yeah.
can afford to enhance their intelligence or their physical abilities or even their lifespan.
Right. It's a really slippery slope.
Now, implantable devices also come with their own set of risks.
Absolutely.
We've all heard about the potential for hacking, data breaches.
Right.
Could someone hijack my insulin pump? Could someone control my neural implant? It sounds like something out of a science fiction thriller, but is it really a possibility?
Well, cybersecurity is a real concern with any connected device.
Right.
And implantable devices are no exception.
Right.
Imagine the potential for harm if someone hacked into a pacemaker.
Oh, yeah.
Or a brain implant.
Yeah.
So we need to make absolutely sure that these devices have very robust security protocols in place.
Right.
To protect against these kinds of malicious attacks.
It's a sobering thought.
Yeah.
What about biocompatibility? Our bodies could be pretty picky about foreign objects.
Oh, yeah.
So are there risks of rejection
For sure.
or complications with implants?
Absolutely. Biocompatibility is crucial.
Right.
These implanted devices need to be made of materials that the body won't reject, and they need to be designed to integrate seamlessly with the surrounding tissues.
Right.
But there's always that risk of inflammation, infection, even device failure, which could have really serious consequences.
Now, the DIY biohacking movement,
Yeah.
it seems to be gaining a lot of momentum.
It is.
We see people experimenting with gene editing, implants, doing this stuff in their own homes, in their garages.
Yeah.
What are your thoughts on this whole trend?
Well, I mean, on one hand, the democratization of science is kind of an exciting prospect.
Yeah.
But it also raises concerns about safety and regulation.
Sure.
I mean, without proper training and oversight, these DIY biohackers could inadvertently put themselves or others at risk.
Right.
So I think we need to find a way to balance, fostering innovation with ensuring that we have some responsible practices in place.
Yeah, I can definitely see both sides of that coin. It's really inspiring to see people, taking control of their own biology, pushing those boundaries of what's possible. But at the same time, safety and ethical considerations have to be paramount.
Absolutely.
Now, we've talked a lot about the physical risks,
the
ethical dilemmas, but what about the potential psychological impacts of all this?
Right.
How might these technologies affect our sense of self, our relationship with technology?
It's a really interesting question, and I think it's an area that deserves a lot more attention. As we become more and more intertwined with technology, it really raises these fundamental questions about our identity.
Yeah.
About our autonomy, about what it means to be human.
Right.
Will we become overly reliant on bio-enhancements?
Yeah.
Will it create a divide between those who embrace augmentation and those who don't? These are really complex questions, and we need to be having those conversations as a society.
It's a lot to grapple with, right? I mean, biohacking is raising these really profound questions about our values, our limits, I mean, the future of humanity itself.
For sure.
But it's not all doom and gloom, right?
No, not at all.
There are strategies we can use to mitigate these risks and to try to harness the potential of biohacking for good.
Absolutely.
So let's move on now to exploring some of those potential solutions.
Okay.
What steps can we take to make sure that all of this is developed and used responsibly?
Well, I think one crucial step is establishing really clear regulatory frameworks.
Okay.
Organizations like the FDA, the EMA, they're already working on guidelines for gene therapies, implantable devices. And we need to make sure that these regulations are robust, that they're adaptable, and that they keep pace with this rapidly evolving field.
So it's really about oversight, but it's also about making sure that oversight is flexible enough to allow for innovation.
Exactly.
Without, completely stifling it.
Yeah, you don't want to, put a stranglehold on progress.
Right.
And it's not just about top-down regulation either. I think we also need to foster this culture of responsibility within the biohacking community itself.
Okay.
Promoting ethical guidelines, open dialogue, sharing best practices, just to try to minimize those risks and make sure that these technologies are used for good.
So it sounds like a really collaborative effort.
It is.
We need the scientists, the ethicists, policymakers, the biohacking community, all working together to try to shape this future responsibly.
Absolutely. We're all in this together.
And we can't forget about the public.
Right.
They need to educate people about this.
Yeah, absolutely.
We need to demystify biohacking, explain the potential benefits and risks in a way that everyone can understand.
Yeah, sure.
This is how we empower people to make informed decisions about their own bodies.
Exactly.
And to participate in this really important conversation about the future of biohacking.
It's about informed consent.
Right.
And empowering people to make their own choices.
Knowledge is power.
It is.
And when it comes to something as potentially transformative as biohacking, we need to make sure that everyone has access to that knowledge.
Absolutely.
Now, technology itself can also play a role in mitigating some of these risks.
It can.
So what are some of the technological safeguards that are being developed to make biohacking safer?
Well, in gene editing, you have things like prime editing, which offers even greater precision than CRISPR.
Wow.
Reducing that risk of off-target modifications.
Right.
And there are AI-driven design tools that are being used to try to predict and minimize any potential adverse effects.
So we're using technology to make technology safer.
Exactly.
It's kind of a paradox.
It is.
But it makes sense.
But it's essential, right? And then for implantable devices, we need those robust cybersecurity protocols.
Yeah.
We've got to protect against hacking, unauthorized access, and advancements in biomaterials are making implants more biocompatible, which reduces the risk of rejection and complications.
It sounds like we need a multi-pronged approach.
We do.
A combination of regulation, ethical guidelines, public education, and these technological safeguards.
Yeah, it's a multifaceted challenge.
It is.
But I think, if we approach it thoughtfully,
Right.
we can create a framework that allows us to explore this vast potential of biohacking while also minimizing those risks.
Right.
And making sure that these advancements ultimately benefit all of humanity.
That's the key. Biohacking, powerful stuff, potential to really reshape humanity in some profound ways. But like we've been talking about, not without its risks and challenges.
Yeah, definitely a field that requires careful consideration.
Definitely a lot of open dialogue is needed, a real commitment to doing this the right way.
Responsible innovation.
So as we wrap up this deep dive, I want to bring it back to a personal level.
Okay.
If you had the opportunity to enhance yourself through biohacking, what would you choose and why?
Ooh, that's a tough one.
Would you draw the line at therapeutic applications? Or would you be open to kind of pushing it further, enhancing your cognitive or physical abilities beyond, what we consider normal?
That's a question everybody has to grapple with themselves, really. There's no right or wrong answer. But I think being aware of the potential consequences, making choices that align with your own values.
Yeah.
That's the key.
It's like we're standing at a fork in the road of human evolution. The choices we're making today are going to have ripple effects for generations.
Absolutely.
So for folks who want to dive deeper, learn more about all this,
Yeah.
what resources would you recommend? Where can people go to stay informed?
Well, the NIH Genetic Literacy Project is great for understanding the science, the ethics of gene editing.
Okay.
They give you balanced information, a wide range of perspectives.
Nice.
And for those who are into the DIY biohacking movement,
Yeah.
BioCurious has a ton of info on their website, community guidelines.
Okay.
They really stress safety, responsible experimentation,
Gotcha.
keeping those ethical considerations front and center.
Those are excellent resources. And of course, we'll keep exploring cutting-edge topics right here at Samurai Kaizen. Hit that subscribe button to stay tuned for more mind-expanding deep dives. But before we go, one final thought. Biohacking is more than just a bunch of technologies.
Yeah.
It's a reflection of our desire as humans to push our limits, to improve ourselves, to kind of shape our own destiny. But as we venture into this uncharted territory, we've got to proceed with curiosity, with caution.
For sure.
Committed to ethical innovation, to a future where these powerful tools benefit everyone.
It's about lifting all of humanity.
Exactly. Thanks for joining us on this journey into the world of biohacking. Until next time, keep exploring, keep questioning, keep pushing those boundaries.
And stay safe out there.
That's it. Like, subscribe, and drop a comment if you have any questions. This is Samurai Kaizen. See you in the next one.